Okay, digital emission modes. Digital modes are very popular with some people. There's some people who hate digital modes because you can't talk to anybody. Of course, that's not true on digital voice, but most of the digital modes, like in FT8, FT4, some of those, um, all you're doing is passing call sign, uh, grid square, and a signal report. You transfer that information back and forth, and that's the extent of the contact. In some of the other modes, it's actually you send messages, so you just type on the computer keyboard connected to the radio and send messages. Uh, and you can send email, you can send telegram messages that way. In the case of the digital voice modes, like in D-Star, you can also send pictures. It just digitizes them and sends them over many, many packets, and you receive it on the other end. But we have some people in the club who are very anti-digital modes. One of the early ones, PSK31. Does anybody use PSK31 anymore? No. That was kind of before, I guess, FT8 and those things came along. I mean, we used to play with it on Tuesdays and Sundays. Now we're doing digital Tuesdays and Sundays. Vara stuff, yeah. Did that use Vara? Vara and January were cold. If grandfather could know. It was called PSK 31 as opposed to just PSK because symbol rate was approximately 31 baud. So that's where the 31 came from. It's also about 31 hertz bandwidth. Which it says is equivalent to about 50 words per minute if you were doing CW, which is really fast CW. It uses what's called varicode. So instead of using like a normal ASCII character representation, um, the binary equivalent of the characters is arranged such that the most used characters use the shortest, fewest number of bits. So instead of every character being sent as X number of bits, they vary from the space, which is a single bit, up to go 6 or 8 characters long for some of the uppercase and special characters. So that's one of the things about it is the uppercase characters, which you don't use as frequently, tend to be much longer than the most commonly used characters. Uh, it's a self-synchronizing code, uh, which means it's able to uh, sync with a pattern on the beginning of it. So because the length of the code of the symbol varies, so it's able to determine where the start and stop is for the symbol. It supports the entire ASCII character set, both uppercase, lowercase, and all of the special symbols, slashes, question marks, all those things. And of course, a lot of those have much longer codes because you don't use them as often. Here's a part of a table, and besides the space, which is a single bit, uh, the E, which is one of the most common letters that you would send, is only 2 bits. And O, which surprised me that it's that common, is 3 bits. I don't have the whole chart on here. I would think that a U is probably a short one also, since it's one of the vowels. It's probably more common. And you can see they go up to some, what is it? 1, 2, 3, 4. See, you got that right? 9? Yeah, up to 9 bits for some of the odd ones. So what type of code is used for sending characters in a PSK31 signal? Again, it's not Viterbi, which is a way of encoding signals. I used to know that because we used Viterbi encoding for up, uplinks on Apollo spacecraft. And it's not volumetric or binary. Which of the following statements is true about PSK 31? Case uses longer sequences and slows down the transmission. We're going to send more bits, takes more time. RIDI. Did you ever do RIDI? It kind of started off with radio as radio teletype, and you used teletype machines, the old ASR and KSR. I think the difference, the KSR actually had a paper punch on it. You could make a paper tape, whereas I think the ASR was just a terminal. So it's been a long time ago. They didn't have the internet when I played. But that was very, very, very old. Yeah, even that was new. Um, okay, so today you do all that with a computer, not with a big teletype machine, which looks like a really big typewriter. It uses what's called Baudot code. There's 5 bits per character, some additional start and stop bits to determine the beginning and end of each character. It uses frequency shift keying, and this is where we call them mark and space. We call a 1 or a true a mark, and a space or 0, and they represent 2 different frequencies. I think they used to be on the test what the 2 frequencies were, but they dropped that. And down at the bottom is actually what one of the old paper tapes looked like. That's how we actually uploaded programs into the Apollo guidance system, feeding in a paper tape actually these were made in Mylar paper, but it was all the code was all on a punched tape. Which of the following describes Baudot code? Was that named after a French guy or something else? That would have to be named like that. Yeah. How are the 2 separate frequencies of a frequency shift keyed FSK signal identified? Okay, whisper. Uh, it's mainly used as a beacon, okay, so that you can uh, detect propagation paths, and especially for lower power things. It sends out a call sign, a grid locator. It's the Maidenhead grids, and the power that is transmitting at. Uh, the Maidenhead. I think it. I don't know if it sends 4 or 6 characters. Maidenhead is actually up to 8. Where we are at EL98. See, I'm up the road on PI 99. So well, that's not quite. We're at EL 98.
So that's all we need to know.
Yeah. Well, when they came up with the Maidenhead thing, they divide the world up into squares. Uh, and you can decode signals as low as 20 minus 28 dB. So it's really a weak signal mode. And that's why they use it on the tracked balloons too. Because you're up maybe 50,000 feet and not necessarily really close to any kind of receiver when you're out over the middle of the ocean. So what digital mode is used as a low power beacon for assessing HF propagation? FT8, okay, can receive up to minus 28 dB. I've managed to make some contacts at minus 18 and minus 20. Canada, New Zealand. Propagation was very good at the time. So in FT8, the stations exchange signal reports along with the call sign and the location or grid locator, and they only use the first 4 characters like EL98. So here they're saying a typical report might be +3, meaning the signal to noise ratio is equivalent to a +3 dB in the 2.5 kilohertz bandwidth. I've seen, particularly Mexico, I've seen a +25 dB. I think they're running illegal. They got to be more than 1,500 watts. And on FT8, I mean, it's supposed to be weak signal, low power. Most people don't do more than 50 watts on FT8. There's always some out there that are. Which of the following narrowband digital modes can receive signals with very low signal to noise ratios? Uh, what does an FT8 signal report of +3 mean? Signal to noise ratio is 3 dB plus 3 dB in the 2.5 kilohertz bandwidth. And you normally look at 2.5 to 3 kilohertz and see all those signals. Packet radio is a digital mode where you actually send packets of data as opposed to just sending symbols. It will be put together in a packet with a header, some access code on the front to allow you to access the packet itself. The header is going to have some routing information in it. And then you have the payload, which is actually the information. And it would normally have the addressee and who it's sent from and the amount of information. It's like this was a letter. And it's kind of the envelope in another package with the header on it. The one at the bottom is just showing a more advanced one where you've got some additional data in there, sync and trailer and things like that. It uses an error detection method so that it can tell whether or not it received the packet correctly. If it detects that there was an error, it sends back a NAK or a NAK response back to the transmitting station. And the transmitting station will resend the packet. If it's a really noisy environment or propagation's bad or whatever, after so many attempts, it will just drop the total connection on the board. That's not a defined number. You can set it in your setup as how many retries. I think it defaults to something like 3 or 5. So if it drops the connection, you're going to start all over. What part of a packet radio frame contains the routing and handling information? Sure. In an ARQ mode, which we didn't define, but an automated repeat request is what ARQ stands for. What is meant by a NAK response to a transmitted packet? What action results from a failure to exchange information due to excessive transmission attempts, when using an ARQ mode? Error correction techniques. If it's an ARQ mode, we retransmit the packets when we detect errors. If it's a mode that has forward error correction, we're actually sending additional information, which sometimes is a duplicate or some other error correcting code, which allows the receiving station to correct for any errors in the received packet. FT8 does that. I forgot the number, but the error correcting bits is equal to or greater than the actual information bits that are sent. Um, 3DV also uses, which is one of the digital voice modes. As far as I know, all of the digital voice modes use forward error correction. I don't know why they just concentrated on 3DV. I didn't make up the question pool. There's a little bit of politicking. It's your KDV command. Oh, is that what it is? Yeah, I wondered. I haven't tried it. I've seen it. I think I downloaded some stuff, but I hadn't played before. How does forward error correction, or FEC, allow the receiver to correct data errors? You think that's it? Oh, any information. They don't use parity bits per se. It's like you wouldn't. Normal parity bit is you go through and you add up all of the bits, and if it's positive or an odd or even, then if you want even parity, you add a one or a zero to it to make the parity, and then on the other end, you do the same thing. And if they don't match, then you say it's bad. But there's no correction. That's a detection method. So is zero even or odd? A zero is even. Mathematically or just logically? Well, it's an even number because one is odd. We can divide zero by two. Sure. You get an answer, don't you? Yeah. Yeah. Just don't divide two by zero. We get an answer there too. Yeah. Okay. To operate most digital modes, you use software like the WS-JTX suite, or another one is FL-Digi, which does some of the modes. And there's uh, I guess VARA is a digital mode, right? Or not? Yeah. Okay. So if you're doing PSK31, you would use FL-Digi. If you're doing FT8, you'd use the WSJTX software. One thing that they both do is they give you what's called a waterfall display, and you'll see that on a lot of the newer uh, transceivers. You'll have a waterfall display. Even some handy talkies, you get a waterfall here. And the waterfall display, there's what an FT8 one looks like. Uh, it's a time record of the intensity of the signals over a range of frequencies. So in this case, it's going to go from, we're starting here at 200 hertz and going up to 2700 hertz, where we're centered about in the middle. So the frequency is going to be on the horizontal axis. The signal strength is how bright these channels are, and they change color. The more intense, the more red they get. And if they're really weak, you can just barely see them. And time goes vertically. So the most recent is at the top, and the oldest is at the bottom, and it keeps scrolling down every time tick. In the case of FT8, it has a 30-second cycle. It will transmit for 15, it will receive for 15 seconds, and then starts over again. So every time it receives, you get an update on the waterfall. And there's none really here. If you see vertical lines on the sides of these channels, it represents overmodulation. I can't say I've seen any. I've seen some where it's bright red and it's smearing out well past the 50 hertz, but I haven't seen lines along the side. So I guess it's just too much power, not necessarily overmodulation. Which of the following describes a waterfall display? Right. Frequency's horizontal, time is vertical, and signal strength is intensity. What is indicated on a waterfall display by one or more vertical lines on either side of a data mode or RTTY signal? Yep. I played with RTTY a little bit. I thought that was normal to have the lines on the side. That's not everyone else. Huh? This country's for everyone else. Well, I thought that's how you lined it up when you tried to receive it. Uh, I didn't do very well on RTTY. I might try it again. Okay, there's some bands where amateurs have to share the frequency, and one of those is the Wi-Fi band, the 2.4 gigahertz. And your Wi-Fi is either on 2.4 or 5. So in the 2.4, amateurs operate, and one of the things that they do a lot, I understand, is take commercial Wi-Fi routers and modify the firmware in it, and maybe even put an amplifier on it, and create their own little mesh networks where they have multiple ones around and they can send packets back and forth. So it becomes a very redundant network. One of them can drop out and you're still able to pass packets from one station to another, find a route through it. And they add directional antennas instead of the little, usually like a patch antenna or a small stub antenna on the router or access point. On what bands do amateurs share channels with the unlicensed Wi-Fi service? On some microwave bands, we've set up mesh networks on the 2.4 and others. So you have what they call nodes. Each station is a node in the network, and they connect to other nodes that they can contact. And it's smart enough that it can route data packets. So it can find a route from point A to point B. It may go through a number of nodes to get there. And if one of the nodes is down, it can find an alternate path. They call that resiliency. So which is true of mesh network microwave nodes? The latest technology that I've seen is the network, the mesh network, which is out to the furthest nodes first. Well, it's been semi-random or pseudo-random. Okay. Pseudo-random. Okay, digital voice modes. Basically, what you're doing is digitizing the voice signal and sending it as packets. The popular ones are digital mobile radio, or DMR, a digital smart technologies for amateur radio called D-Star, System Fusion, or CF4M, and then free digital voice, which is free DV. These all send. What comes closest to P25? Maybe? I don't know. P25 was basically a commercial Motorola, and it's still used for that, but amateurs don't use it much. There's some, I think there's a couple repeaters around here which support P25. All similar from Watchford. I believe the NASA repeater on the VAV does P25. But P25 doesn't connect to the internet, does it?
It can.
Okay. Because I know theirs is not.
Yeah, we ran them through radio.
And that's the big thing about these four. They all connect through gateways to the internet, and you have talk groups for DMR and reflectors for D-Star. And I don't know what System Fusion calls theirs, but I'm sure they have some equivalent groups that you can connect to. And likewise, FreeDB, I haven't played with that, but I assume it's very similar. Which of the following provide digital voice modes? Yeah. And that's it. So who has questions?